Okay, so I'm going to spend some time, okay, not a lot of time going through this handout. Then I will do a quick revision on the energy concepts that we learned last week. Okay, currently Abram and Javen, we are on the topic of energy. Okay, so if your school is not doing that, I'm sorry, but eventually your school will do it. So just pay attention. All right. And then I will go through the questions that we were supposed to do today. So we are going to move at quite a fast pace. I might not have time for toilet break. So I hope you all will bear with me. Okay. Okay. So without further ado, I want you all to take out this handout. Okay. Or those who don't have this handout, can you please look at it? Okay. We're going to look at sources of heat. Okay. So why heat? You all learned that in all the energy that we have did last week, electrical energy, light energy, potential energy, kinetic energy, there's also heat energy. Therefore, there's this topic today. Okay, so heat, okay? Sun is the main source. If you all need to fill in the blanks, sun is the main source of heat. You all need to fill in blanks, right? I think there are blanks on your worksheet, right? Okay, so please fill in. Don't just stare at me like this won't be sent to you again. Okay, so this set of notes won't be sent over to you again. You all have to fill in the blanks yourself. Okay, the sun is the main source of heat. Natural sources of heat includes volcanoes, gases, fossil fuels. Man-made sources are candles, very easy, matchstick. And rubbing objects together, Christina, what does it produce? We did this last week. When two objects come into contact with one another, what do we have, Christina?
Heat.
When two objects come into contact with one another, this thing produces heat. What is it called? Starts with F.
Friction.
Very good. Okay, so these are all sources of heat energy. Now, first thing you need to know is the transfer of heat. Okay, heat always flows from a region of, from region of higher or lower temperature to a region of higher or lower temperature. Hao Qian disappeared. Okay, someone help him. Lilian, heat flows from a region of
Higher temperature to lower temperature.
very good. Okay, until both are of the same temperature. Must remember this. So if I were to take a cup of ice drink out from the fridge, okay? If I were to take a cup of ice drink out from the fridge, Abram, will the drink be at a lower temperature or higher temperature than the surroundings?
No.
Okay, so heat will flow from the surroundings to the ice drink until the ice drink comes to the same temperature as the surroundings. That's how it works. All right. Okay, so take note, okay? When you have a question, for example, in the exam, you see that I have a basin and a beaker. There's a basin of cold tea and a cup of hot water inside. My suggestion to students is always identify which is the higher temperature and which is the lower temperature. So in this case, the hot coffee will be of the higher temperature and my cold tea will be of the lower temperature. So my direction of heat transfer will be like that. So I always encourage my students to do this in the exam to get a better idea of how the heat is traveling. Okay, Casey, can you help me? The cold tea, what does it do? Loses heat or gains heat? Based on the
Gains
graph.
heat.
Oh, good. While the hot coffee, Casey,
Lose heat.
loses heat. Good. And then I need to look at this very important part. Can you help me, Hao Qian, until? Describe the temperature of both at the end. Based on the stuff from the graphs.
Until they both reach the same temperature.
Good. Okay, so until both are of the same temperature. All right, that's all you need to know for transfer of heat. Easy. Okay, the next concept is the conduction of heat. Can you write that down? Okay, so heat conduction.
Do I just write it on a piece of paper?
Who are you? Sorry, Javian, is it?
Javen.
Javen, sorry. Javen, if you want to, you can. I won't know how else to advise you. I tell you what, at the end of this, you don't need to write anything now, okay? At the end of this, you take out your camera, you take when I finish this page, I let you take a picture of it.
Okay.
Okay, can? That makes more sense. Same for Abram. Save you all the copying. Okay, so heat conduction is the flow of transfer of heat, saying from a region of higher temperature to a region of lower temperature. Now, the difference is heat conduction basically is passing through a material. So, in this cup, there is hot tea. Okay, y'all cannot see. Okay, the cup. Now, my hand is going to fill the hot tea because heat from the tea is conducted through the cup to my hand. So think of conduction like a passageway for heat to flow through. So I repeat, heat is conducted from the tea through the cup to my hand, the transfer of heat. All right, so materials have different abilities to conduct heat. Javen, generally, what are good conductors of heat? Start with M.
Metal.
Very good. Metals are good conductor of heat, while non-metals like plastic, wood, okay, they are poor conductors of heat. Please don't say bad conductors of heat. Use poor, okay? Now, the better a material is in conducting heat, Jiaping, the faster or slower it allows heat to travel.
Faster.
Good. The faster it allows heat to travel from a region of higher temperature to lower temperature, which means the faster heat is gained or lost. So, if I have two cups, once again, inside there is water at 10 degrees. I put it in a room at 25 degrees. This is metal. This is plastic. Casey, which cup, the metal or plastic cup, okay, will the water be fuller, be warmer after some time? In which cup, the plastic or the metal cup, will the water be warmer after some time?
Metal.
Good, because this is a better conductor of heat, right? It is able to conduct heat from the surroundings to the cold water faster. Christina, understand what I'm talking about? Okay, can. So now let's look at this diagram. Okay, we have a cup with hot tea and I have rods. So this is the rod. On top of the rod, I have a block of wax. Okay, so take note. I'm looking at heat from the hot tea is being conducted to the wax. I'm not interested in heat being conducted to the rod. The final destination for the heat in this question is the wax. So I'm looking at how fast the heat can travel to the wax, depending on the different materials of the rod A, B, C, D. Abram, are you following? Abram, are you following? I can't see your face. Abram, are you okay? Are you with me? Okay, good. So Abram, the fact that the wax on C, the shortest time to melt, is it the best or poorest conductor of heat? Best. Good. So it conducted or it transferred the heat from the tea to the wax the fastest. Okay, so the wax on A took the longest time to melt, meaning it is the poorest conductor of heat. Now let's look at this application question. If I want to make a container to keep food warm, okay, which material should I use? A, B, C, or D, Javen? I want to have a container that keeps food warm. Which material should I use? Material from A, B, C, or D? A? Why?
I didn't answer.
Sorry. Then tell me A, B, C, or D.
C.
Oh. Hajian, what do you think? C. Agree or disagree? Material to keep, container to keep food warm. Agree. Jiaping, agree or disagree?
Disagree.
My dear boys, Javen, if I want to keep food warm, do I want the food to lose heat to the surrounding fast or slow?
Wait, I think it's A.
Okay, you answer my question. I have a hot bowl of ramen. Do I want the ramen to lose heat to the surroundings quickly or slowly? Javen, slowly or quickly? Slowly, right? So I should choose the poorest conductor of heat. Guys, if I choose the best conductor of heat, my noodles is going to be damn cold very fast. Not ideal. So I want to choose the poorest conductor of heat. So I should choose A. Okay? So A would be the most suitable as the why? As the answer, the wax took the long not that. Okay, wait, sorry guys. As the wax took the okay, I'm gonna use another color, okay, because it's very confusing. As the wax on A. So this is the evidence from the experiment here. As the wax on A took the longest time to melt, suggesting it was the, as I mentioned, porous COH. Conductor of heat is COH. Okay, I just use short form. Hence, I need to explain about the food in the container. Hence, food in the container will lose heat slowest to surroundings and will be kept warm for the longest time. Similarly, if I want to store ice, Lillian, should I choose, if I want to find a container to store ice, should I choose the best conductor of heat or poorest conductor of heat, Lillian?
Poorest.
Very good. So similarly, if I want to store ice, I should also choose A. Because ice will gain heat slowest from the surrounding. Okay, so remember, if you want to find a material to keep your food warm, or you want to find a material to keep your food cold, always choose the poorest conductor of heat. But if you want to make your food gain heat fast, for example, the frying pan, therefore you use metal so that the food will gain heat from the fire very quickly, you will cook quickly. Okay, apart from material, there are other factors that also affect heat conductivity. Okay, the distance or the thickness of the materials. Now, Christina, the thicker the material, do you think the poorer the conductivity or the better the conductivity?
Better.
So you are saying if I have a thick material, it will conduct heat faster. It will transfer the heat faster. Is that correct? Yes or no, Christina? Huh? Really? So if I wear a thick jacket, my body will lose heat to the cold surroundings faster. Is that true? Okay, so I ask you again. The thicker the material, the better or poorer the conductivity of heat? Yeah,